Hey everyone, it's Justin again. You've already learned the two forms for geometric sequences, so now you'll learn how they can be used. Make sure to have a calculator and a notebook handy, because here we go. First, let's review the two forms and how they differ. The recursive form is broken into two parts, the actual formula and an initial term, so we know where to start. The explicit formula has the same information condensed into a single formula. The recursive formula is easier to understand and remember, but you have to travel through each prior term to reach the one that you want. And the explicit form is harder to understand and remember, but it allows you to jump straight to any term you want. Two forms and formulas for the same geometric sequence. If any term is -3 times the previous term, and the initial term is 5, what are the first 4 terms of the sequence? So we've been given this formula in recursive form, and that's a good thing because we need to find the first 4 terms. So jumping to a certain term with the explicit formula would do us no good. We're better off starting at the first term and then just using recursion to find the next 3 after that. The first term is 5, and the second term will be -3 times that, or -15. Then the third term is -3 times -15, or 45. And the fourth term will be -3 times 45, which is -135. So we've got our first 4 terms without dealing with any exponents that are used in the explicit formula. If the nth term is 5 times -3 to the power of n minus 1, what is the 7th term of the sequence? This time we've been given an explicit formula, allowing us to jump to any term we want, which is great because we only need the 7th term here. So we plug in 7 for n. 7 minus 1 is 6. -3 to the 6th power is 729. And 5 times 729 is 3,645. So the 7th term in this sequence would be 3,645. We didn't have to do a bunch of work to find the first 6 terms just to get to the 7th, thanks to the explicit formula. With a first term of 64 and a common ratio of 1/2, what are the first 4 terms in the sequence? This didn't give us either form, but that's why we learned how to write both forms already. We can decide for ourselves which form to use. If we want to find the first 4 terms of this sequence, which form is best? The recursive form. We can quickly find the terms we want by multiplying by the common ratio. Start with 64, then multiply by 1/2 to get 32, multiply by 1/2 again to get 16, and again to get 8. So the first 4 terms of this sequence are 64, 32, 16, and 8. We have the same sequence here, but this time we only want the 7th term. So now which form is most useful? The explicit form, which lets us skip all the previous terms and jump straight to the 7th. We want the 7th term. So n is 7, and 7 minus 1 is 6. 1/2 to the 6th power is something you don't see very often, but an exponent just says multiply that many of the same thing together. So if we multiply 6 1/2s together, 1 times itself 5 more times is still 1, and 2 times itself 5 more times is 64. 1/2 to the 6th power is just 1 over 64. And finally, 64 times 1 over 64 is just 1. So if we start with 64 and keep having it, the 7th term will be 1. Recursive and explicit forms have different uses, so it's important to know when to use which one. But what if you're given the wrong form to start? In that case, you'll need to convert it into the other form, which is exactly what we'll be learning in the next video. See you then!